Welcome to day 10 for Cisco CCNA in 60 days. The book's on Amazon if you haven't already got a copy by the name there. You can see it's version 4, so make sure you get the latest version. If you can, please subscribe to the channel and hit the bell icon so you see the rest of the videos. Starts off on day 0. So we're on day 10 already, which is spanning tree protocol and a few other bits. So today you'll read the cram guide as usual, review yesterday briefly, watch the videos, do the labs, take today's exam, and do subnetting.org or the 101 Labs book if you have a copy. So spanning tree protocols, really important. Rapid spanning tree protocol also is in the exam. It has been for a few years actually, but they keep asking more and more. And then also do the labs. There's a couple of books that will help you if you get a chance. They're both on Amazon. 101 Labs IP subnetting from Zero to Guru. There's also 101 Labs Cisco CCNA if you want to do some extra labs. Alright, so that's all for me today. We'll get into the training video on spanning tree.
Welcome to the spanning tree lecture. One of the longest and toughest areas to get your head around, but the beauty of having a lecture is you can watch it a few times over, make notes, and come back to it again. So spanning tree protocol, the whole point between spanning tree, and we didn't need to worry about this when we had quite small networks, but what happened is once the network size increased, obviously we had more problems, and one of the problems was loops. Layer 2 loops on our network where traffic would go round and round and round the network and eventually bring it down because it became confused, the switches became confused as to where to send the traffic. Spanning tree, in order to communicate, uses something called BPDUs or Bridge Protocol Data Units, and these are passed between switches that are running the spanning tree algorithms. Alright, so a real sort of rough and ready example of how a switching loop happens, but information for a VLAN is sent around the network, and as we know, the information is shared between switches. Unfortunately, the information can come back to the switch which originated the traffic, and at that point the switch becomes confused and thinks that that VLAN is actually connected to another switch. And so when it tries to send traffic to that VLAN, it sends it from the direction it believes where the destination VLAN resides, and of course the other switch sends it back to the switch that it thinks the VLAN resides on, and all of a sudden we've got a major problem with our network and traffic will go round and round and round and round. So spanning tree, the point of it is it decides which ports should remain active and which ports it should block, and the whole point behind spanning tree algorithm is it works out the best path for the traffic for the frames to go from A to Z. Now ports that are closed down with spanning tree can actually be made active later. It does take a while, almost a minute, for the algorithm to run again, but I'll cover in another presentation how Cisco got around these problems. So switch is receiving various bridge protocol data units and it's got to make a decision. The way it does this is it chooses the lowest route bridge ID. So there's 4 decisions that the best bridge protocol data unit is decided by. So bridge protocol data unit, the results are a route switch is elected for the entire spanning tree domain. Now a route port is elected for every non-route switch, so just get your head around this. There's a route switch and then the non-route switches must elect a route port. There's a designated switch for every LAN segment, and every designated switch needs a designated port. So this isn't the root port, it's an alternate path for the traffic to take to reach the root switch. Okay, so the whole point of it is, as I said before, we're blocking down alternate or secondary paths to reach the VLAN on the network. So when spanning tree runs, the spanning tree ports, the switch ports, will transition through phases. Initialization to blocking to either listening or disabled. From listening to either learning or disabled. From learning to either forwarding or disabled. I hope you're taking notes here. Or from forwarding and then forwarding to disabled. Now the port could be left at forwarding, or it could be closed down into disabled state. Alright, so another classic exam question here. The last couple of slides, you could easily be asked questions on this. The STP port states blocking, listening, learning and forwarding, and obviously disabled. So you may be asked, I think it's a bit of an unfair question, but you may be asked on timers how long it takes ports to translate from one state to another. So I've written these down for you. Okay, so each switch in the spanning tree domain has a bridge ID. So this is used in the entire process to elect what your route is going to be and non-route. So the bridge ID is made from the 6-byte MAC address and a 2-byte bridge priority. Now the bridge priority does go up in increments, but it can be from 0 to 65,535. All switches by default have, and we'll see this in a moment, the default value 32,768. So switch with the highest bridge priority becomes the route, but as I've already said, they're all usually set with a default bridge priority. If that is the case, then the switch with the lowest MAC address is chosen. Okay, so show spanning -tree VLAN 2, and it'll show you some of the outputs here. The bridge priority, you can see the priority here, and you can see the MAC address, and there's some other outputs as well, which we'll come to in a moment. Okay, so switch with MAC address A is elected. So they've all got the same bridge priority by default. So it's with the one with the lowest MAC address, and in this instance I've actually made up a MAC address, but A is the lowest out of the 4. Now here's a classic exam kind of scenario. You may want to choose another switch to be your route for whatever reason, in your wisdom as the network administrator, so you can manually set the priority. Well worth remembering this command, and please do practice this on switches as well. Practice it on any switch that will accept this command. So the priorities can go up in increments of 4096 from 0. So 4096, and then if you add 4096 to that, there's the next priority, and so on. The other way is you can set it as a route primary or secondary. Command is spanning -tree VLAN 2 route, and then you can choose primary or secondary. Okay, so we've got a domain here, and this is really important that you practice this on some live switches on your home network or on a lab somewhere. So we want to make switch C our route, so we've set the priority to 0, so it's got the lowest priority. We want to make switch D the second choice, and so we've set the priority to 4096. So show spanning tree, I've put down VLAN 5 because for whatever reason those switches were in VLAN 5. You can see switch C, priority 0, this bridge is the route. Now if a bridge isn't the route or a switch isn't the route, it won't say this is not the route, it just won't have that line, this bridge is the route. and this is switch D, and you can see the priority is 4096 now. Now this can cause confusion, but sometimes, say we've got a VLAN 5, as I already showed you, the VLAN number is often added to the priority. So instead of 32768, it's added the VLAN priority on, and it's 32773. And remember, you can have multiple VLANs running on the same switch. So spanning tree, it works out costs and priority values in order for traffic to traverse the correct exit to get to the route. So these are the default port costs, and the lower speed of the connection, the higher the port cost. So you can see the gigabit and 10 gigabit connections have the lowest port cost. Most common you're going to see are 19 and 4. So show spanning dash tree I've issued on this switch. It's saying the cost for this particular path is 4, so we know that's a gigabit connection. Issued it on switch A here, and it's telling me the cost is 19, so we know that's a fast Ethernet connection, and it's cumulative, so if you've got to traverse 3 switches, it will add up the cost across each switch. So here's an example network. We've got 300 megalinks and one gig link. So for switch D, the bottom right, to reach switch A via switch C, you have to add up the cost, which is going to be 19 plus 4, which is 23. The second best way to get there is across the two 100 meg links, which is 19 plus 19. So we can see, because of this, the route port is going to be the fastest way to get from D to A via C. Alright, designated ports will point away from the route bridge, and it kind of makes sense really, because the route port is going to point towards, it's going to be the fastest way to get there. So the route was, as we said, was the fastest way to get there. Next best option is a designated port. Show spanning tree VLAN 5, and you can see the role of the interfaces on the bottom of underlined and highlighted. The route is in forwarding, cost 23, and the designated port for this particular connection is 38. Now Cisco have improved upon spanning tree because, as you know, there's some shortfalls, and as you'll see in a moment, there's some potential major issues with it. 4 ways are port fast, BPDU guard, BPDU filter, and uplink fast. Oh, and backbone fast, sorry. So port fast, firstly, the switch will presume that there's another switch connected across a 100 meg or faster link. But if you connect a device that isn't going to send a bridge protocol data units, you don't necessarily need to worry about running the spanning tree algorithm on it, so you can disable spanning tree on the port. So port fast will let you, for example, if you're connecting a server or a high-speed connection to a laptop, then you can disable spanning tree. So basically the interface is going to come up a lot quicker. And the command is spanning dash tree port fast when you're in interface configuration mode. Just beware that you shouldn't be plugging another switch into this port on the switch if for whatever reason you wanted to remove that server. BPDU guard. These are all classic exam questions, by the way, so well worth taking notes and remembering it. So this is going to protect a port in port fast mode if for some reason you're off work for the day and somebody decides to plug a switch into that port where you have port fast. If it sees a BPDU, then it will shut that interface there. So pretty handy. BPDU filter, it again protects the port in port fast mode. If a switch is switch attached, it shuts down the port. So what's happened here is the switch is connected. We're trying to run STP on this particular port, and it will be closed down. Uplink fast. So this provides a very quick way for the network, or the switch network, to use on an alternate path. So normally it can take 30 plus seconds for this alternate path to be determined and then brought up, and it changes it from 1 to 3 seconds. So we've got 2 connections going between our two switches, the root port and the designated port. Uplink fast will let that designated port come up almost immediately in the event of a failure of the main connection. Alright, so backbone fast. This is another way of allowing redundant links to come up faster than they would have otherwise. So the connection from B to C is in blocking mode, and the connection between A and B is open for traffic to pass. For whatever reason, the connection between A and B goes down. This port is immediately aged out and moved into forwarding state. So these are all ways to get around the slow convergence of STP. A few troubleshooting tips: incorrect root bridge, incorrect root port, designated port. If there's an incorrect root bridge, check the priority in the base MAC address, because this is what decides the root bridge. You can issue the show spanning -tree and then the VLAN number if it's in a certain VLAN, or the route for a certain VLAN. And have a look at the MAC address and the switch priority. And we've already mentioned this. You can switch with you can fix it with the spanning tree VLAN and then the priority. So the incorrect root port should be the fastest path from the switch to the root bridge. Just remember that the cost is added up. I've said, so if you've got 3 switches, it's going to add the path. It's going to add 2 paths between 3 switches. Show spanning -tree VLAN and then the VLAN number. And fix with the spanning tree, and then you can manually configure the cost. Okay, incorrect designated port. Again, show spanning -tree VLAN and the VLAN number, and spanning tree cost can be used to fix the issue. Alright, so I hope you've enjoyed it. Again, you may want to watch this a few times and take some notes, and then actually configure all this stuff and have a look at the commands on your own switches. Welcome to the Spanning Tree Lab. So all I've done here is connect 3 switches together with a crossover cable. Switch A to B, B to C, and obviously A to C or C to A. So I haven't done any configuration. Now we're looking at the priority of the switch and also the MAC address. If you look back at the slide, how does it decide the bridge priority? Well, if I can just scroll this slide up slightly. Switch with the highest bridge priority becomes the root. I can't scroll this up any further, unfortunately, I don't think. No. After that, if they're all at the same priority, then the switch with the lowest MAC address. So all the priorities should be 32768. But I did mention before that the VLAN number can be added. So show spanning tree, just VLAN 1 because we haven't got any other VLANs on here. So priority here 32769, so it's added VLAN number 1 onto the priority, and all our priorities are the same on all 3 switches. I'm just showing you switch A here. So the next thing is the lowest MAC address. So go back to our diagram. The lowest MAC address out of these 3 should determine the route. So I wrote down the MAC addresses, the 3 MAC addresses, switch A, B and C. I've also converted these into decimal here. So out of the 3, the lowest number out of the 3 is switch C at the bottom here. I'm not expecting you to do your own conversions, I just wanted to show you how it's working on here. So if I go on to back to switch A, so spanning tree enabled, the route ID is this MAC address, ends in B90E, which is the end MAC of switch C. Cost out of either interface is 19, fast Ethernet connection. Interface fast Ethernet 0/3 is the root interface, so this is the best way to go, and our designated interface is fast Ethernet 0/1. You can't see here, but 0/1 takes you to router B, which kind of makes sense then, and 0/3 takes you to router C. If I go into router C, enable show spanning tree VLAN 1, and the thing it will say is this bridge is the root. So we can see what the root is, and then the next thing we'll want to do, which you may be asked to perform in the exam, is make another switch the root. So I've covered the commands in the presentation slides. So if we go into conft spanning tree VLAN 1 question mark, we can either have root and then type primary, or we can set the priority. If you do a question mark, it needs to be in increments of 4096. So I can set it to 4096 or 0 or increments such. So spanning tree VLAN 1 priority 0, press enter. Show spanning tree VLAN 1 and switch C, and it's no longer saying it's the root. It's saying the root ID ends in D65E. D65E is switch A. So it looks like it all went according to plan. If we go into switch A, by the way, if I do a show version, you'll see the base MAC address for the switch. This is where it's gathering the MAC address from, because each port's got a MAC address as well. It's from here. And if I do a show spanning tree VLAN 1, this bridge is the root. So you can see how easy it is. There's two ways you can do it. You may be asked to configure one or the other, or you can possibly choose in the exam. Welcome to Rapid Spanning Tree Protocol. So RSTP is in the CCNA, although not a major part of the syllabus, but you do need to have an understanding of it. Really, this came about because Cisco, as I mentioned in the previous presentation, had developed several antidotes to problems with traditional spanning tree protocol, such as BPDU guard and portfast. So this is a culmination of work after these other workarounds. So network conversions, remember STP, which is standard 802.1d, was invented when networks were a lot smaller, and then as we've experienced a rapid growth in the size and scalability of networks and performance requirements, we've got problems that have come along with it. So 50 seconds to converge your network is really no longer acceptable. It's probably catastrophic for many networks nowadays. So 802.1w standard rapid spanning tree was created. So instead of your 50 seconds, you should have less than 1 second for the alternate path to be found. Rapid spanning tree, you can actually see when the frames are sniffed, the packet type, and I've got an output here. A different type of bridge protocol data unit, and rapid spanning tree can work with spanning tree, standard spanning tree as well, if you have that in other parts of your networks. You should make a note of the spanning tree port states just in case this comes up in the exam. The spanning tree on the left, RSTP on the right hand side. The port roles, root, designated, alternative, backup. Okay, so you can see the alternate port, and I took a slide here from our CCNP notes on howtonetwork.net. The alternate port is non-forwarding port that backs up the root port. The backup port is a non-forwarding port that backs up the designated port. It's also this port is blocked by BPDU sent from the same bridge, so it's providing a redundant path to a certain segment on the network. Now, rapid spanning tree with per VLAN spanning tree. I actually put a definition down here which you can read, but it basically allows for the definition of an individual spanning tree instance per VLAN. So each VLAN is running its own spanning tree algorithm. So VLAN 4, 5, 6, 10, whatever. Now, if you can combine rapid spanning tree with per VLAN spanning tree, so it allows for the definition of an individual rapid spanning tree instance per VLAN instead of the spanning tree, just the spanning tree. Configure rapid spanning tree really easy. There's only one command actually. Spanning -tree mode rapid PVST, per VLAN spanning tree. So this is turned on by default actually. Show spanning -tree summary and it will show you what mode. So we've got rapid per VLAN spanning tree mode. If you're going to try it on your home switches, you need a minimum Cisco 2950 model of switch to run spanning tree, rapid spanning tree. The command won't be recognised otherwise. Welcome to the Rapid Spanning Tree Lab. You can do this on one switch really, you just need to enter one command. So command show spanning tree summary. Give you a lot of information, but what we're looking for is switch is in PVST mode. So conft spanning tree. If you do space question mark, you'll see your options mode, and then we can see we've got PVST or rapid per VLAN spanning tree. If we go back to show spanning tree summary, here we go. Switch is in a rapid per VLAN spanning tree mode. So I think that's as far as we need to go for the CCNA level. But yeah, practice that command just in case you get asked that in the exam also.